Yo, wagwan. Yeah, man. I'm Mr. Garthreed here. We're gonna do a Cape Pure Mathematics Unit 2 question. All right, Module 1 question, which is complex numbers and calculus 2. All right, this is from the May June 2014 past paper. And it says we are to differentiate with respect to x, y is equal to the ln of x squared plus 4 minus x times the tan inverse of x over 2. All right. Now, before I start the question, let me just remind you of some of the rules. All right. These are the rules that I'll be using for this particular question. All right. If you have d by dx of u times v, right, differentiating the product of two functions of x, and that is going to be equal to v times the derivative of the first with respect to x plus u times the derivative of the second with respect to x. And if you have the natural logarithm of some function of x, all right, and you're differentiating with respect to x, then that is going to be equal to the derivative of the function that is inside the brackets divided by the original function f of x. And also, if you're differentiating the tan inverse of some function of x with respect to x, that is equal to the derivative of the function inside the brackets divided by 1 plus the square of the original function. All right. Now, I just wanted to note that the tan inverse of some function can also be written as the arctangent of some function of x. All right. So sometimes you may see arctan as an alternative notation. All right. And you could use it as well. Okay. Let's get right into the question now. So we were given y is equal to ln of x squared plus 4 minus x times the tangent inverse of x over 2. All right. So they told me to differentiate with respect to x. So I want the derivative of y with respect to x. All right. That is represented by dy by dx. All right. Using dy by dx. And that is equal to the derivative of ln of x squared plus 4 with respect to x minus the derivative of x times the tan inverse of x over 2 with respect to x. All right, that is what we have. So we're just differentiating each term. All right, that's how we're doing here. So what I'm going to do now is to just find the individual derivatives. All right, and then I'm going to substitute it back into here. So I'm going to say d by dx of ln of x squared plus 4, all right? That is equal to what? So you differentiate, let's go back to the rule here. All right, you have the derivative of the ln of some function of x. You differentiate the original function, right? That's f prime of x divided by the original function in the brackets. So this is what you have now. So I can now say that the derivative is equal to, when you differentiate the x squared plus 4, you get 2x, right? Using the power rule, of course, that you should know, divided by the original function, which is x squared plus 4, all right? So that is the derivative of the ln of x squared plus 4. Okay, let us do the other one now. So we want to find the derivative of x tan inverse x over 2 with respect to x. Okay, so I'm going to use the product rule here since I have two functions of x being multiplied together. So that will be equal to what? V times du by dx. In this case, v is the tan inverse of x over 2. All right, v times du by dx. So that's d by dx of u, which is x. All right, plus u times the derivative of v with respect to x. All right, v in this case is the tan inverse of x over 2. All right, good. Let's just simplify this now. So we differentiate x with respect to x to get 1. So what we'll have here in the first term is just 1 being multiplied by the tan inverse of x over 2. So it means that my answer here will be tan inverse of x over 2 for the first term plus x now. All right, x is being multiplied by what? So you have the tan inverse of some function of x, right? That's what we're differentiating. Let's go back to the rule. So the rule says if you're differentiating the tan inverse of some function of x, that is equal to the derivative of the function inside the brackets divided by 1 plus the square of the function. All right, that is the rule I'll be applying here. So let's look at it now. All right, so what I will have now is x being multiplied by the derivative of the function x over 2. The derivative of x over 2 is just a half. All right, divided by 1 plus the square of the function. That's 1 plus x over 2 squared. All right, x over 2 squared. Good. So let's simplify further. All right, so this is equal to the tan inverse of x over 2 plus, now when you multiply the x by the half, you get x over 2. All right, so what you have is x over 2 divided by 1 plus the square of x over 2. So this 2 here, all right, will come down in the denominator here. Okay, because remember when you're dividing two fractions, you multiply by the reciprocal of the denominator. Okay, so it means that I will now have x here in the numerator. I will now have x in the numerator, and in the denominator now I will have the 2 comes down, and then that is being multiplied by 1 plus the square of x over 2. All right, and that is the derivative of x tan inverse of x over 2 with respect to x. Okay, so now since I know the derivative of the ln function and I know the derivative of x times the tan inverse of that function, I can now go back here and say, therefore dy by dx is equal to the derivative of ln of x squared plus 4, which is 2x divided by x squared plus 4, right? So that's 2x in the numerator and x squared plus 4 in the denominator minus the derivative of this here. All right, minus the derivative of this. So when you're subtracting, it means that the negative sign will affect each term. All right, so what I will have now is minus, I will have a minus the first term, tan inverse of x over 2 minus the other term, which is x divided by, that's x divided by 2 times 1 plus the square of x over 2. All right, so that is my solution to this past paper question from the 2014. Okay, for the 2014 paper 2. All right, so if this video was helpful for you, please ensure to like up this video, comment down below. All right, if you're not already a subscriber, please ensure that you are subscribing to the channel, and you can also share this video with your friends. Okay, I'm Mr. Garth Reed, student ambassador at the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. Thank you for joining.